Okay, guys, 2.6 expressions for measures. Today your goal is going to be simplify expressions for the measures of geometric figures by multiplying and combining like terms. So this is nothing new, and this idea of combining like terms, it's just not going to go away anytime soon. So make sure that you remember how to do that stuff, all right? Vocab-wise today, get started here, like terms, all right? Like terms are any terms with the same variables and exponents. So as an example, a pair of like terms might look like, say, 3x and negative 2x. That might be a set. You might see something that looks like this too, something like 4xy to the second and 2xy squared. Okay, same variables, same exponents. All right, so we'll squeeze that in there. Today, two operations that we're going to deal with, really, adding and subtracting like terms, and then down at the bottom, multiplying like terms. When you're adding and subtracting like terms here, your definition really says terms that combine when they have the same variable and the same exponent. So as an example, I might have something like 4x to the second plus 2x to the second, and that's simply going to be 6x to the second. I can combine those because they have the same variable, same exponent. So under addition or subtraction, don't lose sight of the rules that we've looked at in the past. Multiplying like terms are going to be a little different today. These are terms that can be multiplied without the same variables. All right? You have to have the same variable and the same exponent when adding and subtracting, but you don't necessarily have to have that when you're multiplying like terms. And as an example, you might have something like 2x times 3y. Under multiplication, you can just put everything together. The 2 times the 3 is simply going to become 6 times x times y. And we'll look at more examples like this here in a second, but I think if you see these ideas of perimeters and area expression down below, I think you'll really understand the difference between adding and subtracting terms as you work through writing expressions for perimeter and areas. Okay, that said, let's go ahead and take a look at some of these examples down here. Let's just assume we have rectangles for all three shapes. And I want you to keep in mind that the perimeter is the distance around. It's the distance around the whole rectangle. And then the area is the number of square units on the, I'll just fill it in, number of squares like this that fill up the inside of the rectangle, okay? So guys, we've talked about perimeter before. We've said simply just take all your sides and add them up. So if I had this situation right here where this is maybe 4x and this is 2y, your perimeter is simply going to be a 4x, the bottom side, plus 2y. Now your top is going to be the same thing. This is also a 4x. Okay, so we have another 4x to add, and I've got to add in that third side, which is going to be plus 2y. And we'll squeeze that in there. Okay. So when you're adding stuff like this, your job is to find out what's alike and what can I put together. Okay. You have some x's up here that can be put together. 4x and 4x will get you an expression for your perimeter as 8x. And then a positive 2y can be put together with a positive 2y to be plus 4y. Now under addition rules, I cannot put those together, so I'm completely done right there. Nothing else can be done. Difference today is this, though. Under areas, if you look at your rectangle, under areas, and recall that your area formula for any rectangle is a length times a width, is a length times a width. Lucy, don't write on my table anymore, all right? Okay. Okay, Lucy? Okay. Sorry, class. My 5-year-old is in here, and she's over there writing on the table right now. She's not supposed to do that. So, all right, back at it. My area is going to be a length times a width. So in our example right here, okay, my length is 4x. So we're going to take 4x times 2y. Now under the new multiplication rules right here, we simply say my area expression is going to be the 4 times the 2 part, so that's simply going to be 8 And then we just put the rest of the variables in there, times x times y. So that would be an expression for your area of a rectangle with a length of 4x and a width of 2y. All right, I'm not liking the zoom, so I'm going to kind of go back to where we were here. Shorten that up a bit. Let's try another one down here, different color. Oh, this would be a good one. Suppose I have this down here as maybe 2x. And maybe over here I've got something like, how about y plus 3? Now guys, anytime you have an expression that's a binomial like this, or in other words, something where you're adding a value to a variable, I always, always, always want you to put parentheses around this, okay? Okay, so perimeter again. Simply add everything up. You've got a top and a bottom that are going to be 2x, all right? So the 2x and the 2x, I'm going to add them together. And then you've got a right side and a left side. Whoops, hang on. I want 2x, not 2y. And I've got a left side and a right side, which are both y plus 3. So I'm going to go y plus 3, y plus 3. And again, I'm adding everything because we're looking for a perimeter. We just add up all the sides. So simplest form of this one right here, your 2x and 2x would be a 4x. You've got one y and another y, both positive, plus 2y. Can't put those together under addition. And finally, you've got some constants of plus 3 and plus 3. So the expression for your perimeter in this given rectangle, 4x plus 2y plus 6. Area-wise, your length times your width. Your area is going to be the length of 2x. And again, anywhere where you have a y plus 3, put parentheses around it. Now, under multiplication rules, I told you earlier in this chapter, do not ever forget about the distributive property because that's what we're going to do. We're going to take 2x times y here to get an area expression. Simply put, it's 2xy. And then the 2x times the plus 3 is going to be a positive 6x. So your expression on area is 2xy plus 6x. All right, let's try another one here. Got a y minus 2 on the right. I'm going to put parentheses around this. So here we go. Perimeter, 3 plus y minus 2 plus the top part, 3 times y minus 2. Okay, here we go. I've got two y's in here. Both are positive, and I forgot a plus sign right there. Squeeze it in there. All right. Let me back up quickly and write this correctly. So I got plus 3 plus y minus 2. Okay, I've got the two y's right in here. So my expression for perimeter, two y's. Now, constant terms, be very careful on this. You've got a 3 here and a 3 right there. 6. 6 minus 2 is 4. Minus 2 more, you're down to 2. So you're going to have 2y plus 2. Okay, area-wise, 3. Length times the width, y minus 2. Again, there's that distributive property. So we're going to have 3 times y, which is 3y. And then the 3 times minus 2, which is minus 6. Now again, if you need to go back and listen to this, feel free to. But as you're making your way through the notes, if some of you guys are a little behind because it's 8:05 and I'm ready to go home and go to bed, have the sub pause it so you can get everything down. All right, but make sure you ask questions, pay attention. Okay, page 2. Let's look at some examples. We are going to look at some examples of simplifying by adding and subtracting like terms. We've done this. We know how to do this. So let's take a look at this. Guys, in this first example, the 3x and the 2x, both positive, becomes 5x. And then you've got a 4y and an 8y, both positive. So you write plus 12y. Okay, under addition and subtraction, I cannot put the x and y together. Only in multiplication can you do that. All right, I want you guys to try the next 4 on your own, I believe. Let me check. Yeah, try these next 4 on your own and see what you come up with. And again, once you've got an answer, check with a neighbor. All right, here we go. I got a positive 5a and a positive 2a, so that's a positive 7a when I put those together. So I've accounted for those. I've got some b's, and I like to keep things in alphabetical order. It's just the way I am. Not necessarily the rule, but I think if you're checking answers in the book, it'd be a lot easier. Okay, 5b doesn't combine with anything. Guys, careful on this. You got a positive 7c and a negative 6c. That sign attached to the 6 is negative. So when you combine those, you're combining a positive 7c and a negative 6c, which is really a plus 1c on the end. Okay? So there is simplest form of number 2. 3. You got 5ab and 6ab. Okay? You got two variables in there, but they're the same variables. So you can combine them. So you've got 11ab. And then you've got a positive 4bc, which would combine with negative 7bc. Okay, positive 4, negative 7 is a negative 3. So I'm going to put minus 3bc. Okay, number 4 gets tricky. We've got some of the same variables, but now we get this idea that, maybe my exponents have something to do with this. And it's true. The only thing that's going to match up here are the y squareds. All right, 2xy is like nothing else in there, and 8x to the third is like nothing else. So the only thing that's really going to work for me in this situation is to call this 8x to the third. I'm going to combine my y to the seconds now. A minus 3y squared and a plus 12 of y squared would be plus 9y squared. Okay, so I'm going to cross these three things out that I've used already. And a 2xy is just left by itself, and you just bring it down. And there's simplest form under addition rules. Okay, last one I'm not even going to talk about. I'm just going to do the work, and you tell me, I guess I really don't need to do any work. There's no other x squareds up here. There's no other xy's together. There's no other 3y squareds. There's no just x's by themselves. And there's no y by itself. So in this one, it's already simplified. You don't have to put anything together. Okay? So under addition and subtraction, look for what's common, put them together. Keeping in mind that the signs in front of the coefficients are very, very, very important. All right. Next page. Let's look at some multiplication here. Multiplication's a lot easier because you can just put stuff together. All right? It's kind of like putting a Chevy motor inside of a Ford body, which is probably a good idea anyway. All right, and 12x times 12x. The note up here says when multiplying, it is possible to combine different variables. Well, in this case right here, I might change the order and call this 12 times 12 times x times x. I'm going to put all the numbers out front. The 12 times the 12 part's 144. And then of rules of exponents we've talked about this year, x times x becomes x to the second. So simplified form of this is 144 x squared. Okay? In my second one, I would call this 7 times 15 times m times n. Okay, gang, your product of 7 and 15 right here is 105. And the only thing that's attached to it is 105 times m times n. So simplified form here, 105 times mn. All right, your next one, kind of tricky. Be careful on this. I'm going to put the 6 and the 14 together. 6 times 14. Now, gang, right here, I'm going to go ahead and pull this c down out here. And then you've got a c squared out here, which really means times two different c's. This c squared right there is in red. All right? Under rules of exponent, this is really 6c to the first, and this is 14c to the second right there. Rules of exponents say that you have the same base, you add exponents. So I can take the 1 plus the 2, or if you count right here how many c's you have, there's 3 of them. So help me out on this. The 6 times the 14 part, what is it? 84. Good. And then, obviously, how many c's after it? Well, there's 1, 2, 3. So I'm going to put 84c to the... Whoa, I almost screwed that up. Okay? Good thing you caught me, Lucy. Lucy, you want to say anything to the class right now? You want to tell them how good of a dad I am? No? How bad of a dad I am? No? Okay. All right. So 84c to the third is what I need there. Here, negative 7 times 6 in example 4 times a times b. You guessed it. Negative 42 ab. All right, my last one right here. I'm going to put the numbers together first. 8 times 6 times 2 times 2. And then all your variables. Times x times x times x times a y. All right, I'm not very good at math, so you guys check my product right here, but I think that product 8 times 6 times 2 times 2 is 192. I have 3 x's, so I'm going to write x to the third times y. So guys, we've been putting a lot of variables together here, whereas on the previous page we couldn't. The idea is you can put variables together and change exponents only when you are multiplying expressions like this, all right? If I go back to the second page right here, I'm not able to change variables under addition and subtracting rules. But on this third page, we were able to get away with that. Okay, hopefully you've got all that down. Again, if you have questions, watch this again. It'll be on your Chromebook. Or just come in and see me tomorrow morning. Okay, last page. We're going to talk about finding volume expressions here, finding volumes of certain shapes. And this right here, the thing you need to understand, the volume of any rectangular prism is found by taking a length times a width times a height. So down here I have a cube, and in a cube all edges are the same, so I might call this 3x, which would make the width 3x and the height 3x. So my volume of this cube, how many cubic units fill this up, would be 3x times 3x times 3x. Okay, so simply put, this becomes 3 times 3 times 3 times x times x times x. All right, the 3 3's product is 27. Down here you would have x to the third. Okay? All right, so I'll give you a couple here to try, and then I'll just throw the answer up there here in a second after you've tried them. But let's go ahead and call this maybe 2x, maybe 2x here, 2x here, and maybe 5xy. So take a minute and see if you can't come up with the volume expression for this. Okay, what I'm going to do is I'm going to take the 5 times the 2 times the 2, that is 20. So I've accounted for multiplying all of those together. I've got 1, 2, 3 x's, so x to the third. Those are all gone. And then finally you've got a y left on the end. So the volume of this is going to be 20x cubed y. All right, last one, let's look at one where we have to distribute a little bit. Let's go ahead and call this 2x for a length, 2x for a width. And how about maybe y plus 4? Keeping in mind, if you ever have an expression that's a binomial like this, always put what around it? Yep, parentheses. All right, volume, here we roll. This becomes the following. 2x times 2x times that binomial of y plus 4. All right, I'm going to work out front here first with this. I'm going to go 2x times 2x, which is my 4x to the second. And that's still times y plus 4. Okay, now we got to distribute. Rules of multiplication, help me out. 4x squared times y. What is it? Well, what did I just say? I just said 4x squared times y. There it is. Okay, then the 4x squared times the positive 4 is going to become 16. That's the 4 times 4 part. And then you've still got x squared attached to this. Okay, so like I said, gang, there's a lot of notes here in a little time. Hopefully you got everything down. That's the main part. If you're confused about something, take this time to go back in your Chromebook and kind of hear it again. But assignment-wise, the sub will get you that here in a bit. And I always encourage you that if you're not sure about something, come in and ask questions. All right, so be good to the sub the rest of the day. Make sure you're on task, and I will see you tomorrow. Have a great afternoon.